So, hello from my side. My name is Todorovic, and I'm coming from the University of Belgrade Faculty of Mechanical Engineering, Department of Process Technique and Environmental Protection. In the next few minutes, I will try to present you the most important facts for the poster named Effect of Substitution of Old Coal Boilers with New Biomass Boilers on the Concentration of Particulate Matter in Ambient Air, a case study, Mionica. Namely, residential and commercial solid fuel burning in stoves, small and medium combustion plants have been designated as the largest sources of fine particles with serious impact on air quality, climate, and human health. Having in mind the age and condition of the plants, as well as domestic raw lignite of poor quality, which is widely used in this kind of plants, this problem becomes even more pronounced in Serbia during the heating seasons. An additional reason for such high dust emissions certainly lies in the fact that most of these combustion units, in addition to being in very poor condition, work without any flue gas system for dedusting. Also, the mentioned lignite is low calorific with high ash and moisture content. Replacement of such combustion units with modern biomass boilers or other units is certainly appropriate, and in places where, of course, natural gas is not available energy source, this kind of boilers could be the best solution. Considering that even the screen models, which are the lowest level of air dispersion modeling, are not done for such kind of, let's say, project or plants, with low installed capacity. The motivation for this study is to use an advanced model to give a representative assessment of the impact of such plants on the PM concentration. In this poster, or in this paper, or in this study, and for the case study of Mionica town, it's the one town in the middle of Serbia, the influence on the concentration of PM in ambient air will be presented by replacing two old coal boilers with new biomass boilers, namely two old boilers with same thermal capacity of 950 kilowatts covered the heat demand of the sports center as well as primary and secondary school. These boilers were replaced with two new biomass boilers of the same installed thermal capacity. In order to analyze the influence of boilers substitution on PM concentrations in ambient air, the regulatory air dispersion model, ARMOD, recommended by the US Environmental Protection Agency, is used. Air dispersion modeling within this study includes only sources which are associated with this case study. Other sources of emission and background pollution are not included. Of course, the aim of this study is not to show the air quality in the model domain, but rather to provide a representative assessment of the impact of boilers substitution on PM concentrations in the model domain. For the purpose of this study, SRTM1 maps are used, and they are pre-processed in AirMap. It is the, let's say, auxiliary tool for our model, while meteorological data processed by another pre-processed model of AirMet are site-specific MM5 modeled hourly meteorological data set for full 5 consecutive calendar years. The results presented in this paper were obtained using a model which includes the emissions of TSP, PM10 and PM2.5 for old and new boilers. Emission inventory, of course, which is probably one of the most important part, has been prepared based on sampling results for both old and new boilers. So we have the measuring results, and we use the emission factors for particle size distribution proposed by US EPA AP42. Modeling results given on the poster consists of graphical so-called isoplet diagrams with ground level concentrations for all PM fractions discussed in this study, of course, and various average periods for 1 hour a day and the heating season. And the heating season in Serbia is started on October the 15th and ends on April the 15th. Of course, we don't have time to go in detail in these results, but instead that I'll give you and I show you this table with the maximum expected concentrations for each of the listed PM fractions and the averaging period, where very high reduction in concentration can be observed as a direct consequence of used fuel, combustion process, and applied abatement measures. Since the other parameters, we can say this, let's say, conclusion because the other parameters important for dispersion are very similar for both cases, and it is important as well to mention that old coal boilers worked almost without any abatement technique, and new biomass boilers has multi-cyclone as system for dedusting. That's it from my side, and thank you.
Thanks. I have one question. Since the paper partially considers residential fuel burning, can you talk a bit about population density? Does that play a role in a number of boilers that are used, and how can that be modeled in your approach?
In this specific case, I mentioned that these boilers are for let's say primary, elementary, and high school in this town of Mionica, as well for the sports center. So the demand for heat demand for those institutions was the reason why this is so high. Let's say 1 megawatt, more than 1 megawatt install capacity. But if we're talking of let's say heating the residentials, it depends, of course, of the density, and it depends, of course, of the let's say the number of population in that area. This it is important to say that these boilers are, let's say, in downtown of Mionica, and this is very important since there is a high population density around these boilers.